Hello, this is Che, and I'll be showing you how to get a graph that meets the following requirements. See these requirements right here? That is what you want to be doing. So we're just gonna start a new one. I've already hidden all these things right here. So y equals divide by. So first we want x-intercepts of x equals -4 and x equals 2. X-intercepts are when the numerator is equal to 0. So if we have x equal x plus 4 right here and x is -4, this is 0. So this is a correct numerator. Same for x equals 2. This part we'll worry about later. So vertical asymptotes. This is when the denominator is equal to 0. And we all know when the denominator is equal to 0, then it's undefined. So we're going to have x equals -2. So we're going to put that right here. As you see, that makes it 0. And then x equals 3. So x minus 3. Now we want a whole at x equals 1. So a whole is basically when both sides are equal to 0. So we want it at 1. This makes both sides 1. And it makes, if we zoom in, it makes 1 undefined. See, that's a hole in our graph. Now we just need to alright. So now we have to get the function to stay on one side. Actually, no, let's do the end behavior first. So let's show y equals 2. As you can see, we're already very close. We have an end behavior 1, so all we have to do is multiply the whole graph by 2. Now, let's focus on this. The function should remain on one side after touching x equals 2. Right now, it goes down and then comes back up. We don't want that. So, as you can see, this happens at x equals 3. To solve this problem, all we have to do is put a square root over here. It makes it into a curve instead of the thing we had before, which was a diamond. We don't want that. We want a curve. But that's made our in behavior 0 because it made the numerator coefficients. The numerator x powers bigger than the denominator x power is bigger than the numerator. So to fix that, we just put x here. See, now we have solved the problem. As you can see, once it hits 2, it goes up instead of going down below the x-axis. Let's focus on an x end behavior of y equals x minus 2. I already have that right here. This is what we want. So to do that, we get rid of x minus c. Let's use d instead. So as you can see, we have this right here. Oh yeah, we can also get rid of this coefficient because we don't need that for the end behavior anymore. We could just play with this d value until we get the correct one. Oh yeah, it says remain on one side, but I feel like 4 directly on the x-axis doesn't count on the other side. So I think we're fine. But as you can see, we played around and 4 seems like the correct answer. You could also get 4 by expanding this and then also expanding this and dividing them. And then the result, without the remainder, we don't care about the remainder. The result will be your D answer. You just have to do a bit of simple algebra after that to get D, but it takes a long time. So I'm just gonna brief you over it. Like it uses polynomial long division with these two values right here. But that's it. Let's see if I have anything else to do. Audiences. I guess we could check our answer. So vertical asymptotes at x equals 2, x is 3, and one more in between. So we have one here, we have one here. So x equals 2 minus 2. See, as you can see, we have an asymptote right here. X equals 3. Have one right here. And I actually didn't have to put one in between. I guess we could count this one as an asymptote. If we really have to. This one right here. Yeah, you saw it, right? Yeah. And now we have x-intercepts at 4 and 2. 2. Oh, this is supposed to be minus. So we also have one here. We have those requirements, minus 4 and 2. That's what we want. And then it stays after touching 2. So you can see it doesn't cross the x-axis. And in behavior. So this eventually meets up with the line of y equals x minus 2. And if we were to hide this and show our first equation we made, this one, it matches up. Okay, I think that's it. Thank you